Alright, so for the setup of the reflux that we're doing in this lab, there's a few things we need to take into consideration. So one of them, first of all, is that the height of the ceramic pad should be high enough so that the Bunsen burner, first of all, can fit, and also high enough so that there can be a small flame to heat the reaction mixture. We don't need a big flame, but we need a small flame, and we're going to need enough space in between here so that the small flame can heat without touching the ceramic pad. So the round bottom flask here, which contains the reaction mixture, it should be slightly above the ceramic pad. It shouldn't be touching. So as this proceeds, vapors come up here. So in terms of the condenser, the water, here's the condenser here, water goes in through the bottom, flows, and out through the top. That's how water flows. So the water goes in, and it cools the vapors, and then it comes back out. It flows that way, in through the bottom and out through the top. So reflux. What's reflux? Reflux is when the vapor from the reaction mixture travels upwards, and then it becomes condensed because of the cool temperature of the water, and then when it becomes condensed, it falls back into the reaction mixture. So the first clamp, the one that's clamped here at the round bottom flask, that should be secure. But the one that's higher, the second clamp, the one that's closer to the middle of the condenser, it should be secure, but it shouldn't be too tight because we don't want to crack the glass and or break the glass. So where does the hydrogen bromide gas come from? Well, in our reaction mixture, we have sodium bromide, and we also have we have sulfuric acid. And what happens is that the sodium bromide dissociates, it creates bromide ions, and then we have our sulfuric acid, and it will donate, the sulfuric acid will donate a proton to the bromide ion, and it'll create hydrogen bromide. And this is where the hydrogen bromide gas, the noxious gas, comes from. So the way that because it's toxic, the way that we prevent breathing in hydrogen bromide, we do this in two ways. So one of the ways is that at the top of the condenser, we have our vacuum takeoff adapter, and there's two parts to it. So there's the top ground glass joint, and then there's like the bottom ground glass joint. So on the first ground glass joint, we put a secured stopper here so that the vapors don't get out. The hydrogen bromide vapors are not going to get condensed because their boiling point is much, much too low. So we do this so that it stops the vapors from going out so we don't breathe it in. Another way that we do this is we have a rubber tube going from the bottom ground glass joint of the vacuum takeoff adapter, and it goes to a inverted 60-degree glass funnel, and it's connected to the tube as well, and it's inverted and it's placed into about 1 or 2 millimeters of about 80 millimoles of an aqueous sodium hydroxide solution. So this also protects us from noxious gas exposure because the strong base will react, the sodium hydroxide will react with the hydrogen bromide, which is the noxious gas. It'll neutralize it, and it'll make it so that we can't breathe it in. There won't be any more hydrogen bromide because it'll be neutralized in the reaction here. So that's the other way that we protect ourselves from inhaling